Hi chat, welcome to another stream. Oh, I'm zoomed in real far today. There we go. How y'all doing today? It is December 23rd of 2023 and we are back for yet another stream. I don't super have a plan today, but beyond catching up on AOC and got a handful of little open source things to do as well. So we'll try and get those done. I'm a bunch of days behind, and I'm hoping I can catch up because I want to do day 25 live, and be caught up for that. So, yeah, that's the plan for today. Let me say hi to everyone who's here. Beldathis was here before the stream started and was first. Hello, hello. Good reminder to open up my little notifications because I did not do that. Cool. All right. We've also got JJMC who's here. We've got Meat Sauce, welcome back. FizzBuzz, good to see you again. And MDS Ubuntu, hello, hello to all of you. Speaking of Meat Sauce, resubbing at 10 months. Thank you for your continued support. It's great to see you again, and I hope that you're doing well. Yeah, let's jump into some ASC, I guess, real quick on here. Don't show. All right, good job, me. Don't do that. JJMC has resubbed. Oh, why is the hype train different? Oh, are there special emotes? Exclusive emotes? Are they bringing back the special emotes that maybe I don't have? God, I hope I have Haha Cat. No, it's probably a new set of them. Oh, I'm so sad. I'm not gonna be able to get the. I'm not gonna be streaming enough during the holidays to get them. The Max Burn. Hello, hello. Wait. Do I know you? You sound familiar. You've just said hi there in chat 4 times though, so I don't know if you're the person that I know. Beldathis has resubbed at 3 years. Holy shit. Good to see you. Thank you for your continued support. Appreciate it. The other server is also here. Hello, hello. All right. We are on day 18 and it's currently released up to 23. So we got to do 1, 2, 3, 4, 5, 6 of them. Fuck. That's a lot. Michael PC Gamer, hello, hello. Welcome, welcome. Shmuel is also here. Alright, and we got a keyboard warrior in the background. Why is your keyboard so loud? I'm a gamer. Okay. I think I found a way to finally get keycaps for my weird German keyboard. Oh, custom made. That's cool. Ethan is also here and is resubbed at 4 years. Shit. God, I've been streaming for a long time. It's good to see you again. I hope you're doing well. And I hope your new job is have you started yet? I forget. I hope it's going well either way. Alright, day 18. Let me jump right in. Hex colors. Oh, interesting. Or at least it looks like hex colors. All right. Dig plan. Oh, it's Phil? Wait, do we also have a... Is there also a... No, there is not. This is the plan. Got it. Alright. This is our input. Cool. 6 colors! Starting November, have the week off, which is nice. Nice! Good to hear. Digger starts in a 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left, or right, clearing full 1 meter cubes as they go. Oh god, cubes. Okay, we're gonna have to deal with 3 dimensions in the second part, almost certainly. Much more respectable, this number. Okay, so we have to fill again? It looks like. So we have to inside outside again, probably. So and it looks like we don't care about the colors for part 1. Okay, that's not too bad. What? What the fuck? Am I too old? Signs point to yes. Oh no. Alright. So we don't care about the colors in part 1, which is suspicious. But yeah. And let's see. Write 6. So 1, 2, 3, 4, 5, 6. Okay, so we start it here and we apply the directions each time. Okay. Okay. Right is direction for not. How did I name these? I think it's dot right. Oh god damn it. Supports poor dot pie. It is. Okay, right. And left is direction for dot left. Is it you? Yeah. Direction for dot up. The direction for dot down. So we're basically doing the same thing that we did in part day whatever the fuck the first one was. Where we're filling the insides. Yeah. Oh, there's new hype train emotes. What did I get? Hype nudes. I received nudes. Everyone else received nudes too. Oh no. They haven't made new hype emotes in a really long time. Do I just do the same approach as the filling that I did last time? It's not haha cat, it's true. I will never get haha cat. I'm so sad. Yeah, so I don't super know how I'm going to figure out what's inside and outside. Or I don't know of a smarter way to do it than the last time I did it, so we're just gonna do the same approach. Yeah. Okay, so that gets us all of those. Then we look at whatever day it was that we did the filling part. Was it? Maybe. Shataz, thank you for the follow. Welcome, welcome. Hopefully you're doing well. 14 is definitely one of my longer ones, so it could have been that one. No, 14 was the... It was day 10. It was 10. It was my longest one, yeah. Baldur Van Mountain says, "Do you think Santa will bring me a PlayStation 5 this year?" I don't know. I'm pretty sure part 2 is going to be 3-dimensional space though. So we're gonna have to do a 3D flood fill. Ooh. That's gonna suck. Okay, so all right, bx equals support dot bounds scene. So now we're gonna build chords out of that and do the flood filling. Been super kind last year. I don't know why he wouldn't. I mean, depends who's mind controlling Santa. Okay. For y in range -1 by dot max plus 2. For x in range -1 bx dot max plus 2. I can just say chords equals I wonder if we can get away with just counting the inside ones and just flood fill the outside. That's what I'm gonna try and do. It might be good enough to do it, but yeah, so if we have the size of outside and we have the size of chords, then we can just return this, although I suspect that we're gonna have like the weird bubble around inside part, and then this won't work. But Spitfire, thank you for the sub with Prime, appreciate it. But if this is good enough, then I am okay sticking to it. Like I'm okay taking shortcuts knowing that they're not precisely correct. Oh, this is supposed to be Raytheon, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Spitfire says Merry Christmas. Silly Laird is here. Hello, hello. Do you think Santa will bring me a unified Python packaging ecosystem? No. I think the packaging ecosystem will continue to be fractal. Yeah, so that passes the test. I suspect it's not going to work though. Urbanoff, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Yeah, too high. Yeah, that's what I thought. That's what I thought. So there's the same bubble as day whatever the other day was. So I gotta actually inside outside this one, which is fine. Yeah, so we gotta do the same traversal a second time and fill the inside. Yeah, that's fine. Stir, what am I doing? Int. We got to run this again. We don't have to do this. Setup tools, distutils, hatch, or something else. Well, there isn't. Distutils doesn't really exist anymore. It's just setup tools. Okay, so we need to have a thing. Actually, for any of these, it's just clockwise and counterclockwise. DDLs, thank you for the bits. All Vimbits is currently disabled, but I'm gonna owe some at some point. But it's good to see you again. Yeah, I can just counterclockwise and clockwise. If can't, not in. If what? Yeah, if can't, not in outside. Then flood. Fill. Yeah, we can still flood fill with our coordinates because we have our coordinates. Inside. Yeah, I think that's right. Oh, we get a much bigger number. Well, that's not good. How is that possible? Now I should get a much smaller number. And then get our path in there. That's an even bigger number. Fuck me. To do Python type challenges. Oh, that sounds fun. Mike239X. Hello, how you doing? Yeah, we went in the wrong direction here. So what did I miss? Well, let's print our thing and see what it looks like. Figure out where I'm going wrong here. I might need to. That's kind of big. Oh. Did I just do -1 and just assume that? Yeah, that's the problem. uh, I just assumed it started at 0, 0. It doesn't start at 0, 0. That's almost certainly the problem. The x dot min -1, y dot min -1. Okay. So now it should be better. Yeah, that's a smaller number. Hooray! I might not have needed to do the thing I did, but good enough. Good enough. On to part 2. I'm a little nervous about what part 2 is gonna be here. Because it sounds like it's gonna be in 3D space. Much too small. Don't stop the color and instruction parameters and producing the dig plan. The first 5 digits encode the distance. Oh. Oh. Well then. Oh boy. Yeah, this gets a lot harder. We basically need to figure out squares. Yeah, it's gonna make a bunch of squares, overlapping squares. Gonna look around to get inspired and do some game jam coding. Nice. Yeah. Ooh, this is gonna be a tricky one. The last hexadecimal digit encodes the direction. I see. I assume our input is the same way. Okay, that's not too bad, although my approach doesn't work at all. Because I'm not computing as squares. And holding all those points is going to be much too big. But we can collect all the points. And then fill, hopefully. We should be able to build a bunch of squares, I think. I hope. Ooh, very, very tricky. Wait. RDLU. RD lift up. So really just have a bunch of corners here. Ah, it's in parentheses annoyingly. And with an extra thing on it. So we're gonna regex this. We want two capturing groups here. We can just do the whole thing here. Oh, this is... Oh, we can't have a variable look behind. Damn it. Alright, I'll just do a search then. Actually, we can do... We can do that. Da, 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 da. It's unfair. You can write regex so fast without help. Ah, it's fine. Let's see. N and D equals int match 1 16 and there's match 2. And actually, I don't need all these look ahead, look behind them. I was getting too clever here. Let's just do let's just do the whole pattern. Since it doesn't actually change anything. And then we can just match on the line. Let's make sure that that does the right thing. Those if I can syntax properly. Gonna lurk around and get inspired, do some game jam. Oh, I already read that. Nice. Nice, nice, nice. Alright, PN, PD, P line. Int 70C71 in 6 space 16 is the right number. And match 2 is 0, which is right. Okay, cool. I think I can do d dot apply pause n equals n. Our pause. Yeah. Okay, so that gets us our corners. Heard there was libass here. We're gonna be doing some libass at some point. Okay, so my thought on this is we're gonna have 2 corners and we're gonna be able to trace out each of their squares. And did I write a thing to do square intersection? Probably not, but I'll probably have to do it again. 5 stream watch streak. Ooh. Oh, we got a new theme. I usually turn that off during AOC, but I guess we can have it on. We're not trying to be competitive here. All right. Let's see. Print corners. PP corners. So I got a big chunk of corners here. I could have gone with hot dog, true. So we actually know these 3 will always be... Like, I think you'll always be able to find But there's gonna be internal parts, which is annoying. I guess we can just keep reducing the problem down. So if we can find a point that has 3, we can change this into a new thing and then just solve it recursively. I think. Like if we take our original problem here, we have, at the start, we have these 3 corners. And I think as long as we don't see anything else in this range, we know we have a rectangle that we can chop off, and then we have new corners here. And you can just keep doing that until you run out of squares. This doesn't have any like kind of interesting ones though, because they all sort of match up here. What about our bottom right corner here? We got big ol' number here. We have 2 points. Oh, we have so many points that match this one though. I'm gonna fill up my water. I will be right back, and then we'll start trying to chop off squares. I'm back. Alright, so I've been kind of thinking about this problem a little bit, and I think we're gonna need to do some drawing. My hope is that we can basically split the problem into a bunch of squares. There is sort of a problem in that, like, I kind of want to go from the bottom up, or not squares, rectangles. I kind of want to go from the bottom up, but I think a shape like this is going to be tricky to think about. Because I think I was hoping of just saying, like, you know, go to build this rectangle. Like, you're at this point, I can find this point easily, I can find this point easily. But I think, like, because there's points in here, this is tricky. Now, I can see logically that I want to find how to get this segment here and build new corners there. And basically, like, chunk off parts until, I don't even know if that would be the chunk I would do here, but basically subtract out squares or subtract out rectangles until there's nothing left. I kind of want to see how many points are in the actual problem just to, like, get an idea of what I need to think about. There's 680 corners. Yeah, so there are quite a few corners here, but I think that idea will work. And just subtract out squares. And I think there's only the two cases here. Like, if I start from the bottom right or the bottom most, maybe I just start from one direction. I should be able to find, like, this is the max X. And I can find the largest low. Not always going to be laid out like this, which is fun, I guess. And it's not always, like, a corner's not always going to be internal too. Yeah, like, what if your max X is not your max Y? I mean, in theory, I should be able to start from any point and make squares somehow. But then my worry is that I end up, like, I don't want to I don't want to cut a piece in half like this, and then I'd have to solve two problems. Although, maybe it's fine to solve two problems, because oh, and actually, tracing the outline, keeping just the corners, I lose information, because if I trace the outline, I know what corners are connected to what other corners. So I can use that information. Kind of curious if we ever see the same corner more than once. We just see the origin. Okay, cool. Okay, so that helps a little bit. So then I can know what things are connected to each other. So I kind of want to record the forward and backward of each of these. Okay. So instead of having this, we have forward and backward. And it's more confusing than it needs to be. So then we can say forward prev equals pause and backward pause equals prev. And so that should give us all of our corners and where they come from and go to. So if we say forward of 0, 0 and backward of 0, 0, then we know all of the points that we have. So we need to be able to take that and reduce it down to a rectangle that we eliminate in a smaller problem. And we've gotten to a point where there are only 4 left, then we know we are done. So that's the terminating condition. I'll shorten that just because I know I'm gonna be annoyed typing that over and over. I actually don't care about the dimensions of this. So actually these can just be integers. But he says, what's an AOC time? Fancy you ask. There's a command for it. Yeah, if we have this, then rect.append, but we can just take any point from this and find its forward and backward. And multiply the differences. So one of these is always 0, one of these is always 0. Alright, let's see if this like very simple base case works. Try and make an example for this. So we have just so we need to go down, which is 1. It's lowercase. Then we need to go left, which is 2. Then we need to go up, which is 3. So this should be 5 times 10. 50. Oh, right. So I can just say while true. And break. Where it says hint, you have to program really, really goodly. Hooray! Okay, so our base case works. If we can reduce it down to this case, we're good. But that is the tough part. Mike239X says true words have never been spoken. Yeah. Okay, so we just need to be able to chop off rectangles somehow. I think if we try and find, like, say, if we try and find this shape, we can always figure out, like, what in, well, not necessarily, because it could be like a bend. I think I want to try and find this shape. Somehow. Or this shape, I guess there's 4 shapes I can find. We can find any of the U-bends. So any shape that looks like this, or this, or this, or this. Those are all good shapes to find. Because what we can do is chop them off. Nick says, which day are you doing now? I'm doing 18. I'm behind. Yeah, I think we'll always be able to find one of these shapes. And then we can use those to reduce the problem. Oh, except there is a weird edge case in that we need to find these without any junk inside. Because we could have something that looks like this, and then so like even though we have this shape here, we can't just cut off here because we have points inside. It bit you. You get zapped? Oh, hello. How you doing? But in this case, we know we can find this one here. So we really want to be able to find. We want to find that shape without anything inside of it. How did I? What the fuck? YouTube auto-played me to Christmas lo-fi. I don't. That's not what I want. Not what I want at all. Do I have to turn off? They break this like autoplay thing all the time. Because I'm playing a playlist. It should not go to random garbage. I should continue playing my playlist. What are all the color codes in the input about? They're not relevant for part 1. For part 2, they are the actual numbers. Bill says, doing great, having a holiday till the end of this year, working on a Python RSS sentiment analysis project. Ooh, sounds cool. Yeah, so we're looking for nubbies that don't have anything inside them, basically. Now, how to do that? I guess we can just go through every point, and when we find one, we can try and eliminate it by detecting one of these patterns. Which actually, knowing the original input is a little bit useful here, because this is, you know, U, R, D, and this is R, D, L. Yeah, so like we could, so I would have to go back and get the data back from that. Although as soon as we eliminate one, then we don't know those anymore. So deriving it is probably fine. Okay, so I'm going to loop through each point, and if we find one that's in one of those shapes, then we know we can eliminate it. In one of those shapes and doesn't have any of the other points inside of it. All right, so for what's that? What are you grumbling? Is the dryer not figuring itself out? Is the auto dry not working? I'm confused. Oh, why does that mean you're cosplaying as the dryer? I'm very confused, as you can tell. Okay. All right, so we're looking for up, right, down, or right, down, left, or down, right, up, or left, down, right. So we only are looking forward? I guess? Hi 3x. Okay. Now we need to determine the direction that it went. And there's 4 for each of them. Gross. Okay, this is gonna be a lot of gross code, but I think it will work. Alright, if p2x is greater than p1x. Oh wait, I actually need one more, because there's actually 4 points here. Fuck. We're gonna make a little function that determines this too. Um, 9 to 5 office worker, you should not listen to anything that person says. Because they have no fucking idea what they're talking about. Actually, maybe we just do, maybe we don't split these out because I don't think we actually need to yet. If you don't know who they are, don't worry about it. You're not missing anything. Yeah. Basically, the entire platform of this person is to try and stir up shit and then get into drama wars with people. Right, p1x p1y equals p1 p2x p2 p2. If p2x is greater than p1x, return direction for dot right. If p2x is less than p1x, return direction for dot down. Left. That's yeah. P1y is. We'll write them the same way. P2x is greater than P1. P2y greater than P1y. Then it went up. P2y is less than P1y. Turn direction 4 dot down. Should never hit this other case here. Okay, so now that we've found those, need to figure out. I think we're always going to match one of these 4 shapes. No, because it could wobble up. Yeah, like we could see this shape, and so that's the shape that we don't want. I wonder if we ever see something that does this. I wonder if we ever see anything like that. I'm gonna parse our input because this is gonna throw off our thing, and really we would just want to treat this as one line segment. Let's try and find that first. We never hit that breakpoint, so that is a good thing. Okay, so we don't have any of those weird ones, fortunately. And I don't ever use backwards, so I'm just going to get rid of it. I mean, I do use it here, but we can replace that with something else. We can just go forward twice. Just go forward once, or go forward twice. Oh yeah, going forward twice is always going to give us the opposite corner. So we have 2 corners. And then we just do abs. You're starting to like the new typefair syntax. Oh, nice. I mean, it certainly makes it easier if you're just doing little challenges. With shorter syntax, less to type. FD is not used. Neither are these. Okay, so now that we have found our directions, we have we have to figure out the various shapes and their sizes. Okay. Shouldn't be too bad. All right, if but we also have to find them in the reverse direction. Yeah, we actually have this, or we have this. Those are the same though, because we're trying to find this part here. Yeah, so these are the same. These are equivalent, or we can treat them the same. And we would pop this and replace it with a new segment here. Basically, we're basically reducing a big ol' linked list that I've done as a dictionary. Boga, hello, hello, how you doing? Yeah, there's 8 cases. I think I'm gonna write them all out separately. And then figure out how to reduce it down. Okay, if we're up, right, left, then our candidate is so our top right. We're gonna find our top right. Our top right is always this point. And then it's the minimum of these two. So it could be either of these 2 points, depending on that. So this is always going to be P2. And then this is always going to be the X of P3. And then the minimum of, oh, actually maximum, because, no, minimum, closest to 0, of P1's X, or P1's Y and P4's Y. P1 Y and P4 Y. And then we need to check if all of the points are in there. Let me write one more of these. This isn't actually the full D1, D2, D3. Oh, this is supposed to be down. Up, right, down. Up, left, down. In this case, the top left will be P3. And the candidate bottom right will be the original point, the x of the original point, U1x, and then the minimum of P1 and P4. I did y here. So these look very similar, except their point. No need to bang my head with the variance shenanigans. True. True. Oh. Okay, so if this rectangle does not contain any points, then we can chop one off. Key. And then we need to eliminate points. And potentially add new ones. Van Doven says, hell yeah. Hell yeah. Oh, but this is going to be a lot of fiddly copy paste code the way I am approaching it right now. But maybe that's okay. We need to figure out which one we're keeping here. Because we keep one of these points and we eliminate the other one. Maybe we say that separately instead of this cutesy min here. Oh, what if they're equal? If they're equivalent, we can actually kill both of the points. So there's more cases. So if we say if P11 is greater than P41, Then this is so gross. uh I think I'm gonna make a point class just because these X's and Y's are annoying me. I might already have one, but we're gonna make one real quick anyway, even if I already have one. Oh, but we don't have... We don't have things in here. I guess we can do P star. Ugh, I need to use the restroom. I'll be right back. Hello, I'm back. I just thought of another problem with this idea. We figured out all these shapes, but what if we see this shape? We would detect this as potentially one of the things, but... What do you mean, what is this? We would detect this as one of the shapes, but I don't know what is the inside and what is the outside. So we got a whole different problem here. We have a whole different problem. So how does one determine if we are inside or outside? This is something that I should have figured out in the earlier day problem, but did not. And so now I'm gonna have to figure out how to determine from a set of directions whether we are inside or outside. Ugh. Inside is warmer than outside. Probably cold outside right now. Yeah. Yeah. Damn. Hmm. I wonder if we find the bottommost line segment, then this direction is always outside? That true? I think that's true. If you find any of the extremes, we know, which is kind of the same idea that I used before. Is that true though? Yeah, I think it has to be. So that'll tell us inside or outside. Yeah, so let's try and figure out inside or outside first. We can actually do with any of the 4 sides, like maximum. Like if the maximum x going up or down, well actually, yeah. At the maximum x, if we're going up, then the right is the inside, and if we're going down, like we have this here, we had to have come into like this. Then we know the direction. I think that's correct. God, I hope it's not wrong. Otherwise, we're gonna build the wrong structure here. Sure. If priv 0 is greater than max x, then max x equals priv 0, max d equals d. So let's try this on our little simple case here. Yeah, if we're at our max direction, we can only be going vertically too, because it's strictly greater than. Just gonna set an arbitrary one in here. I don't have to worry about none. And this actually eliminates half of these, I think. Because even though we could see both of these, if this is the inside, we only have this one, because this would be outside here. So that cuts our problem in half. Kind of. All right, let's see what it gives us. Cannot determine the type of priv 0. Oh, actually, I think this needs to be here. XD was down on our simple example. So that means let's see what it is on all the other ones. It's down on this one too. It's down on that one also. Okay, so I'm just gonna cut corners. Okay, so we only have to worry about the right-hand curls. So only these 4. Because the left-hand curls will be outside. Okay. Cool. So then this one isn't possible here. This one's easy. If they are the same, then we eliminate these 2 points and then connect these 2, I think. So basically we had P1, 2, 3, 4. These were at the same Y level. And so we just deleted that. Actually, I don't think that breaks my code, because if we have this sort of thing, it'll make these 3 line segments the same. I'm just gonna break one here. Okay, so let's figure out what we need to do for these two. So we kind of do need the reverse mappings. We need to go backwards here to find the point below it, figure out what it points to. So we'll put backward back. Which means we need to do way more way more surgery to to undo these. You know, I'm not gonna keep track of backward. We'll just have a really slow lookup to find backward when we need it. Which is fine. Arrow Bounce! Thank you for the reset, but 26 months. It's good to see you again. I hope you're doing well. Damn, I have spent fucking 2 hours on this one problem. This doesn't bode well for the rest of the day. Alright, let's implement contains point as well. A day is pretty difficult. Nice. Is it points? Yeah. Spent 2.5 hours working on last night's on a tablet. Only to figure out I double paste the input? Oh no. I spent like 4 hours on a problem once only to realize that I had fucked with the input. I know that feel. And I'm doing strict containment here because I don't want to find the 4 corners that I'm already looking at. Oh, but we don't know which of these is. We don't necessarily know this is top left, bottom right. Turns out getting your word per minute deflated by 10x is also really painful. Yeah, I can imagine. Yeah, we don't necessarily know. These aren't necessarily top left, bottom right. This is just 2 corners. So we have to. Well, if I just do min, I think it knows what I want. Yeah. There's a lot of sketchy assumptions going on here. Yeah, this is definitely going to break something. But I'll get to it when I get to it. Let's try and solve these other parts. Oh, we also need to actually... need to actually do this. We need to break. Mad106 man, thank you for the follow. Welcome, welcome. Hopefully you're doing well. And we're gonna do a reverse. Because I didn't actually make my reverse lookup. Okay, in this case we're keeping P1 and we're... Oh, we actually don't need the reverse lookup for this one. Convenient. But we're still always deleting these two. So we can say that forward P1 goes to a new point, and that new point is so this case is looks like this. So it's the same y as P1 and the x of P4. 4.x and P1.y. And then forward of new point is equal to forward of... Oh wait, no, it's just P4. P1 goes to the new point, which is going to P4. We're cutting out P2 and P3. That seems fine. I think this also has the same problem as I was talking about before, which if we have something that looks like this, we're gonna chop this off here, and we need to figure out those directions and potentially eliminate line segments. So I'm gonna have to maybe we'll just do like a fix-up routine that just goes through everything. It'll be kind of slow, but there's not that many points, so it should be fast enough. Yeah, let's just implement the fix-up because I'm pretty sure we're gonna need it. How do I do this without... How do I mutate the dictionary? Well... Maybe we just fix it from a particular position? And what if a fix-up needs a fix-up? I don't know. Gross. Oh, I guess we can do this. Yeah. What's up? Ooh. Yeah, are they open today? Yeah, I'll zingies. Yeah? God damn it. I don't know. I don't know what I got. Something like that, yeah. Is the avocado or something? Cheese? Yeah. It's not regular. It's small and regular? Oh. Love Keys here. Hello, hello. How you doing? Okay, we gotta do this last one here. So we know what our C2 is. We have this case here. So we have our new corner. We have to P1 to our new corner and a new corner to P4. Forward P1 equals. Oh, we need to make a new point. It's not our corner. So our new point is P1's X and P4's Y. Yeah. And then that point connects P4. Gotta fix up. And then this. No pickle, please. Okay, so that's one of the 4 curls. So let's figure out how to generalize this to everything else. So we've done this one. We need to do right, down, left. This is our next one, and then I'll figure out how to make them similar, so it's not just all copy paste. Right, down, left. So I specifically chose this corner, so let's choose this corner as well. That will make it more similar. C1 is P2. So then we need to figure out X direction of that one. What? Bye. Where are you going? Oh, you're picking up. Ooh, fancy. Oh yeah, you're right. Yeah. Have fun, DoorDash. I'll miss you. Bye. Cucumbery new. I don't like that. Hey, what's up there, Armchair General? Hello, hello. Oh, we gotta write this big old fucking set of if statements again. Alright, but instead this time we're looking at P1's X's instead of Y's. If P1.x is, put it in the same structure as here, is greater than P4.x, okay, what's gonna change about these? Alright, so we have up, right, down is going to give us, this is always going to be our corner, that's fine. We're always deleting 2 and 3, that's also fine. Saren, thank you for the follow. Welcome, welcome. Hopefully you're doing well. We are comparing y's. And we want the minimum. But here we want the maximum. Yeah, we want the highest y. And then blah, 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 fix it. For our new point, it's always going to be P4. So it's keep x. Why did I do? Oh no, that's right. Yeah, we're keeping x from P3 or 4. Actually, I think it's easier to reason about if I say this is 4. And then these are the same. Except for this one. Wait, no, they're not the same. Yeah, that's fine. It's not necessarily that. Okay. For our corner, we're keeping x though, and we're comparing y. Okay, so that's up, down, and right. Let's do the next one, which is right, down, left. Right, down, left. Our corner 1 is going to be P2, which is going to be this one here. So our bottom right is keep y. Keep y. And then we want the maximum x. Okay. I think this is enough to give us like a pattern and delete most of this code, which is good. All my accounts ban says your keyboard smokes me. Interesting. All right, so we have down, left, up. Down, left, up. Corner 1 is still gonna be P2. And then corner 2 is, we're keeping the x of, keep P4.x, and then compare P1, P4y, and I think we want the minimum here. So if we have this, oh wait, no. We want the maximum y again? The biggest y in this direction? Oh, actually, we wanted the minimum y here, right? Ran out of room. So here, we wanted the minimum y. Yeah, so I wrote this down wrong. is when this was bigger than P4. P1 is bigger than B4. Did I write this wrong? I think I wrote this wrong. Oh no. The code that I was trusting. P1 is greater than P4. So P1 is greater than P4. Because Y goes in this direction. Then we should have kept P4. And so we should make a new point. This should be the new point here. So we're gonna get good foundation programming. Practice. Build stuff. Build stuff for yourself. Here is my advice on that, just in general. Okay, yeah, so if P1 is greater than P4, then we want P4's Y because it's the minimum. Our new point is now P1's X and P4's Y. And we go from P1 to that point, and then from that point to P4. Okay, so this, I'm confident with this. That looks good. If they are equal, then it doesn't matter which one we use. Let's just say that we use P4 to be consistent. We can actually just say C2 is P4. And we can just say that P1 goes directly to P4. And delete the inner two. Okay. If P1 is less than P4, then we want to use it. Our corner is going to be P4's X. P4's X and P1's Y. And our new point is going to be P1's X and no, that's not right. This is P1. It's going to be P4's X, P4's X, and P1's Y. And we're going to go from P1 to that point, and then from that point to P4. Okay, so interestingly, these are the same here. But the point location is different. Okay, that's fine. Okay, I think this code is better now. Let's go back to the down, left, right one. So down, left, down, left, right, down, left, up. Down, left, up. And so we want the maximum Y. And our last combination is left, up, right. Corner 1 is P2. Corner 2 is I'm just guessing minimum. And that we're going left, up, right. P4 is Y. All right, so with this, I'm gonna try and simplify this code down. so I don't have to copy and paste this and write the same thing 4 times with mistakes. 09 Uzdev, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Corner 1 is always P2, so we can already say that. Corner 1 is always P2. And then it's really just like max, min, max, and which we keep. Uh, 09 Uzdev says nice keyboard, and Texas PB says nice setup overall. I'm glad you like it, Texas and 09. I'm drinking my water too fast. I gotta use the bathroom again. At least I'm hydrated. It's Blammy. Hello, hello. Good to see you. It's been a while. I will be right back. I'll see you in a sec. All right, we're back. We are back. I kind of feel like I need to find a way to simplify these three if statements because it's going to be tricky to do with all of these. I wonder if we can also make this less special. Like, what if this were just the same as this up here? What would happen here? Our new point would be P1x, P4y, which is the same as P1x, P1y. So the point would just go to itself. So I think we can just make our fix-up handle that. So I think we'll just change this to greater than or equal to, and then improve our fix-up. Oh wait. If it points to itself, we've broken our chain because we can't figure out what it would go to after that because it's not actually a doubly linked list. Oh, but if we set it to ourselves and then we overwrite it here, so this works only because I do them in the right direction. So we set P1 to P1 and then P1 to P4. So this gets clobbered by this. I think that's fine. Yeah, I hope so. And then is there a way to simplify this down more? Probably not. Okay, so how do we represent this set of conditions here? I think this will just be that. I think that's all we actually need to understand this. And so then we can say choices is equal to so this is keep is 0 and compare is we'll just say GTE. Oh wait, but we want minimum. So let's say that it's less than. And we want the maximum here, so we'll just say greater than. We know that when it's equal, it's fine because we do them in order. We just need less than and greater than here. All right. Keeping x, changing y, and compare is maximum. And this is keeping y, changing x, and maximum. So, this actually isn't a dictionary. Oh, we've got an arch cringe lord in the chat. Hello, hello, welcome, welcome. I do find it funny that people try and base their personality on an operating system. Okay, so I'm going to reorder these if statements to better match the structure of what I just wrote. Then we're going to try and do this with a loop. Let me change from a dict to a tuple because we're not actually, we don't use it as a mapping. We only use it as a sequence. I had a question. I opened my Penguin because I don't have Windows and I saw a big shiny thing that let my eyes hurt. What is the big shiny thing? Beats me. Oh, but we can't use our little break trick that we had before. It's fine. I mean, if we do use it as a mapping, then we don't have a loop. Maybe we change it back to a dictionary, even though it doesn't really belong as a dictionary. I will unreorder that in a second. And then we want to reorder these. Okay. The C1 is always P2. Actually, before we do this, I'm going to copy this chunk out in case we have to go back to it. Because I'm pretty sure it will work. And we would just have to copy and paste it 4 times. Alright, let's not start with a typo. Great. If choice config dot compare. Oh, actually, what are we trying to do? Are we trying to get our corner? Our corner is always C2 choice config dot keep equals p4 choice config dot keep. All right, so this should say like if it's 0, then we've put the x into here. Otherwise, we need to find the y based on the other value. It's less than, we keep it. So then we say if what's up, Cellular? You already said hey. Hello again. Well, I missed Skye, but how you doing? Shouldn't the last compare be LT like you wrote? Did I write GT again? Yes, yes, it should be. Probably when I went and undid all the things, then I had fucked that up. Thank you, thank you. P1 choice config dot change or so if it is the correct value, then we pick y from point 1. Otherwise, okay, so in this case, if P1 is greater than P4, then we keep P1's x. If P1 is greater than P4, keep P1's y. Okay, yeah, that looks good. So that gets our C2. We also need to figure out our new point. I think the new point is always just the opposite. So oh, this is interesting. Same y, opposite. Wait, this is same y, same x. I feel like, did I typo this? Let's go back to our drawing. Alright, P1's y is less than P4's x. Or P1's y. I'm running out of room. We need new paint. So we have this case, and we have this case. So this is the less than case. So we're making a new point here. That is actually, this is C2 and new point. In the greater than or equal to case, we're making a new point here for C2. It's also the new point. Oh no, wait, that's not the corner. This is the corner over here. Oh, that's why it's confusing. So I think we could actually just say P3 is the corner in this case. That will make the code simpler. Yeah. So if this is true, then C1 is equal to P2. Otherwise, C1 is equal to P3. And then C2 is just our cut point. Yeah, that makes this much simpler. And then we can say, if not contains point, C1, my pad's gonna have a fit over this, but that's fine. Oh, but we've not converted this properly. Let's do this, and so that we're not changing the types all over the place. Typing passes. It's part 1. Got my hopes up. This is running 5 ever. Oh, you logged out of chat and forgot you said hi. That's fine. Hey, what's up, Wilfred? Sorry, it's been 5 minutes since I paid attention to chat. All right, we are never finding a choice. So let's see what happened here. Right up right. Okay, that is not a nub. Up right up, also not a nub. Right up right again. Up right up again. Right up left. So far we've kind of spiraled up and now turned left. And now we have up, left, down. Well, this is really weird. Left, down, left. Down, left, up. Is that one of our things? Down, left, up. Hooray! We've, in theory, found a nub. Okay, so we've eliminated a nub there. Are we winning? No. Maybe soon though. Okay, so that's that first one. We need to run this with -s because we're getting lazy in printing. Okay, so it found one and eliminated it. And then it found nothing. It didn't even find any potential ones. Okay, that probably tells me that we're eliminating something wrong. I should try this with the smaller problem. Just because I know how that one works. So let's try and re-encode the original small problem as a test case. Down is 1. Why am I trying to do this manually? Computers are great at this. Let's fucking do this. Do 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 do. That correct? 0 right, down 1, left 2, up 3. Too many values to unpack. Expected 3. Getting sloppy. I want to say it was 62 before. Let's put 50 in here. We're finding no candidates. We should find one immediately in that problem, right? Because we had right, down, left. And we have a right, down, left here. Oh, did I not run it with a dash S? Is that why it didn't do anything? Right up. Fucking A. Okay. Yeah, these are backwards. Should write a little test for that. Right, down, left. Alright, I'm getting cocky. Let's remove our breakpoints. Key error. Tina! It's Sammy time! Okay, so we had a number failure and a key error. Goodies! I haven't played. Why a bowl? Why with a bowl? What? You? Who is Sammy? A sandwich that I'm going to be eating. Thank you! Thank you for the sandwich, Tina! I've had the sandwich before, and I've had the sandwich before on stream. But it's been like a year. Hold on, I'll show the sandwich in a sec. I get all the paper nonsense out of the way. Tina, are you sure this is mine? Can't tell if this is cheese or chicken. You have my sandwich, I think. Oh. Okay, I'll be right back. What? I was gonna say, this looks like chicken. Alright. Have sandwich. Oh, I'll just put it on that camera. Yeah, there we go. It is avocado and jalapenos and cheese, and I have a spooky knife to cut it because I'm gonna eat it with a fork. Zithrius, hello. How you doing? I'm gonna eat it with a fork because otherwise it's going to be a mess. At least I'm going to attempt to eat it with a fork. This is a terrible idea. I have We'll make it so you can see me eat it. Who's ahead? Who's ahead of what? Real Python moment? Yeah, giant knife cutting on my lap. What could go wrong? Eating sandwich with fork. Yum. Yeah, it's crunchy too. So I'm curious how I ended with such a small number here. My guess is some of the points that I'm passing in here are wrong, and so it's ending up being 0. But we will debug that after I eat. Because I was starting to get so hungry I couldn't think straight. That's you don't want that. Nobody wants that. And I don't have a steak knife, so that's why I'm using this like horribly large knife. Because I felt like butter knife was not gonna cut it here. Zoom in on sandwich. There it is zoomed, but not higher quality. I guess I can show it on the main camera zoomed in. You don't care about the code? Yeah, I don't have a scene for this. Come on, focus on the sandwich. Ignore my face. My face isn't here, camera. There we go. Oh. Sandwich! Hooray! Yeah, I don't have a good scene for this, so you're just gonna have to deal with this. I'm gonna try and put the mic over here so you don't get all my chewing noises too. But yeah, the AOC problem I'm doing today is quite tricky. I think if I would have just copy pasted code, I would already have the answer, but I didn't feel so great doing it that way. So that's why we're trying to do it the hard way. I think some shortcut I took is messing me up, fortunately. Oh, actually, now that I'm thinking about it, I'm pretty sure I know right where it is. Keyboard camera is the old main one. Yeah, I have a better camera to replace the keyboard camera with. I just haven't done it yet. It was the one that I used to watch the well, it used to be the old kitchen camera. And it was the one that I used for the 3DS camera. I'm glad that I decided to eat this with a fork. This is gonna be an absolute mess otherwise. The crunch is so good though. Crunch is my favorite flavor by far. I know it's not a flavor, but That is what I say all the time. Crunch is the best flavor. Microphone is covering the sandwich. Can you still hear me over here? Is that better? Texture, yeah, texture is the right thing, but I think it's funnier to say flavor. Yeah, this sandwich is good. Just the way I remember it. Although, actually, I don't remember the red peppers in it. It has red peppers and jalapenos. I kind of remember the jalapenos, but I feel like they used to be fresh and not pickled. But still pretty good. I'm not really a fan of pickled things. I don't know. Yeah, I see my problem here. Pretty sure this line is wrong. This line has to be whatever the opposite of this is. We're looking at this is super hard. If we look at this original one, the X did vary based on which one we were picking. But in the original one, we only had one choice for the one corner. I know they like people say, "Don't eat at your computer; you'll get it gross." Yeah, I'm trying to be careful. We don't make computer gross. Cutting at this angle with this knife is I'm a little spooked. I also feel like this sandwich had more cheese before, but it's fine the way it is. Hey, what's up, Sarcastic Dante? How are you doing? Good to see you again. Vanox is also here. Night Owl No Italics is the current theme, yeah. A gift from D-Dolls. The Numa Saika, thank you for the follow. Welcome, welcome. Princess says, what advice would you give to a Python? I don't know what DS is. data science, the developer something. Used to have a background in humanities, transitioned over coding. Solid skills, but not track record of experience. Are you trying to get your first job, or are you trying to grow in your career? Because getting your first job is always the hardest part. You okay? What happened? Too much gamering? From climbing? Oh no. But yeah, my advice in general to like gain experience is like, if you can get a job, get a job. Otherwise, build projects and always practice your trade. Work on open source. Build things for yourself. Try and, you know, the only way to improve a craft is to practice it. Of course, I mean the other part is to get advice from other people that are good at it. So if you can find people to work on stuff together in open source or otherwise, like that's nice as well. But my recommendation is almost always projects. Like almost all of the stuff that I have learned is from doing random shit that I want to see. Bother me on Discord, yeah. Now you're hungrier, Numasaika. Well, tough. I'm hungry, so I'm eating. Yeah, today you're getting programming stream with side of eating. Nah. It's working great though. What? Oh. Yeah, I'll clean it later. Oh. AOC mukbang ASMR, yeah. Kind of. We started with that, yeah. When they knew it was crunch. Yeah, it was unintentional the first part, and I was like, I don't know that anyone wants to hear my chewing noises. Neil says, is Julia language any better than Python by syntax? I mean, syntax is always going to be subjective. I haven't written enough Julia to actually have a good answer about my personal preference, but I don't think the syntax is what matters about programming languages usually. Yazalak, thank you for the follow. Welcome. You know someone named Julia. I know at least one person named Julia. Yeah, that basically counts. I don't know anyone named Python. Why do you say yet like you're gonna name a child Python? Alright, I'm gonna take this downstairs. I'll be right back. All right, we're back. Put all my junk back in order. And can't forget the bee. The bee. The bee. They're already in their spot. Mr. Python. Hey, what's up? Tic Tac Boom. Hello, hello. I know a guy named Python. He's a bit of a snake. Yeah. Python Marcus Satilli says Wilfred. It's spelled wrong. Wait on it, chat. Wait, what? 24/7 newsroom. Hello, hello. How you doing? Mr. Python? Yeah. Why doesn't every fucking language just use one syntax with different implementation? Because people have preferences. Why don't we have a single way of transportation? Yeah, there you go. Dark Slayer, hello, hello. Welcome back. Wolford says, what do you think of the name I gave your child? I don't know. I don't think I could name a child Python. That seems rude. We've also got Monster God. Thank you for the follow. Welcome, welcome. Never forget to put your junk back in order. Yeah. Something like that. Okay, yeah. So the problem isn't this. The problem is we need to pick... P4. So these just need to come from the opposite one. I think. Unreachable. We got a point equal to itself. I thought that was supposed to be impossible. We also got 25 for this first one again. So there's more bugs to chase. Alright, let's see. What am I doing? That's not syntax. Yeah, so there's parts where we're computing the area of 0. So we've definitely fucked something up somewhere. New Year's resolutions get good scrub, 1080p and 4K. Yeah. Okay. this is going to be a bit of a pain to debug. But let's try walking through when we do an elimination on the simple problem. All right. P1, P2, P3, P4. So we should be looking at Starts by going right 6. What is our directions here? Right, down, left. So right, down, left. So we're looking at this chunk here. 0, 0 to 6, 0. 6, 6, 5 to 4, 5. Yeah, so these are our 4 points here. And so C1 is P3. 1, 2, 3. This is one of the corners. This is the corner we're going to generate. Which should be at x of 0, or x of 4, 0. So right here. Great. So we should chunk off this rectangle here. Oh, motherfucker. Oh, there's at least a bug. All right, 4, 0. That looks good. Does not contain any points. Oh, annoyingly, pretty print will sort them. We don't actually want that. We want them in the insertion order. Which is this. And so P1 will go to this point here. We'll delete these two, and then this point will go to this point. And then hopefully we will fix up that one. So 0, 0 to 4, 0, and somewhere in here, 0, 0 to 4, 0, and then 4, 0 to 4, 5, which is here. And so after the fix up, it should go from 4, 0 to 4, 7. And it does. Okay. All right, so we still have more problems. We have closer number this time. And part 2 is looping forever. Should always find something to eliminate, so we'll put 4 else there. Flavor Horror, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Let me select our particular case here. Right, it's gonna have a new line in it. Okay, we'll do this. Oh, I just clicked the wrong thing. Okay, so 6540, that's the one that we saw. That's this one, which is good. And then it eliminated 67 to 49. 67 to 49. That's not right. 0, 1, 2, 3, 4. Oh, this is 4, 9. This is 6, 7. Okay, yeah, no, that's fine. It eliminated this rectangle here. And then it was 0, 7 to 1, 5. 0, 7 to 1, 5. That is not right because it should have contained these points here. Oh, my containment function assumes top left, bottom right. Yeah. Yeah. Alright, so let's try this again. 6540, that's right. 6749, that's right. This one failed. 0715. 0, 7? One, 5. So that's this nub here. I'm gonna print out the forward also. This requires a set, but we don't actually have a set, which is fine. Just stop the bugs, no need to chase them in any game of tag? Yeah. This is less useful than I thought it was going to be. I'm gonna make it draw the whole thing instead. That is not gonna be helpful. Never mind. We're gonna figure it out manually. Okay. So we got 6540. That's this one. Yeah, we already know about that one. 65. Wait. X4, Y0. 6540. Okay, yep, that's that one. Awesome, Early. Hello, how you doing? Anthony of Code, yeah. Then 6, 7, 4, 9. 2, 3, 4, 5, 6, 6, 7, and 4, 9. With that little chunk there. Okay. Then we have 0, 7, 1, 5. 0, 7, 1, 5. Yeah, so it should kill that nub there. I'm surprised that it didn't kill this nub here, because we should have seen a down, left, up. Oh, but it contained... No, it should have been this little square here. Oh, perplexing. Chair, hello, how you doing? This is still a correct elimination though, so that's fine. Then we kill 0, 2, 2, 0, which is this nub here, which is fine. And then we eliminate 2, 0 to 4, 5. 2, 0 to 4, 5. That point shouldn't exist. Okay, so there's some nonsense happened in here. Let's trace it more specifically now. I think the bug is in the eliminations, but I'm not certain. Like, it might be the equals case. Yeah, it might be the equal case. Alright, C1, C2. Song loops. Oh, I've gotten all the way through this amount of the playlist. Alright, 6540. And we should have gone to 40 and then 40 to 47. Yeah, okay. Joker's Yard, hello, how you doing? I'm working on AOC, it's in the title. You can also look at today or AOC. Joker's Yard, thank you for the follow, welcome. Okay, so that one looks fine. 6, 7, 4, 9. That's 6, 7, 4, 9 down here. Okay, so we should still go 0 to 4. We should go all the way to 9. We should have 4, 9. 4, 0. 4, 0 to 4, 9. Then 4, 9 to 1, 9. Yeah, that looks correct. 2, 0, 4, 0, 4, 0, 4, 9, 4, 9, 1, 9. Doing only Python this year? I'm not gonna have time to do another language. I'm gonna be honest with myself. Okay, so that one looked fine too. 0, 7. 0, 7. And 1, 5. That looks correct. Let's see what we have now. Okay, so we should go 0, 0, 4, 0, 4, 0, 4, 9, 4, 1, 1, 9 to 1, 5. 4, 0, 4, 9, 4, 9, 1, 9. 19 to 15. Then 15 to 25. Yeah. Okay, so this still looks fine. Okay, so now we have 0 to 2 0. This one up here. And so we should just have 0 2 down to 2 5 or 2 0 2 0 to 4 0. Yeah, that's fine here. We should have 2 5 to 2 0. Yeah, that looks fine as well. Yeah, this still looks correct up till here. Then we have 2 0 to 4 5. What do we have left of this damn thing? We've cut off this. We have these two rectangles left. So we have 2 0 to 4 5. We have this chunk in here. I actually think is correct. It actually looks right. And then we just have a square left. And none of the eliminations have been 0. Oh, am I like double counting the edges? We're failing to count the edges? I'm probably failing to count the edges. Let's see. What are all the edges we would have? We would have... this is the first one. 1, 2, 3, 4, 5, 6. Where 1, 2, 3, 4, 5. Doesn't really make sense. I kind of feel like I'm double counting the edges. I'm reducing. I feel like I'm reducing the problem correctly, except the last one feels a little bit strange. I guess I could draw it using my original code. 19 to 15. 25. Yeah, I'm pretty confident in that. Huh. There's probably edges. Edges that are a problem. Let's see, what if we print the edges? It should be P1 keep. Zero, 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 zero. What? 6, 7, 8, 9, 10, 11, 16. That is not our number. What the fuck? What is going on here then? Is my area computation wrong? Alright, we'll print the area as well. I wonder how many rectangles we have at the end. Six? No, that doesn't help us. ASC is a competition? Kind of. It's len rex minus 1 times 2, but I don't think that's right. Let's print our area and see what we get here. Also print this one up here. Okay, so 2 in the x direction, 5 in the y direction, we added 10. 2 in the x direction, 2 in the y direction, added 4. 1 in the x direction, 2 in the y direction, added 2. 1 in the x direction, 2 in the y, added 2. 2 in the x direction, 2 in the y direction, added 4. 2 and 5 is 10. Plus 12. What? 22, 26, 27, 28, 9, 30, 31, 32, 42. What the hell? Am I missing just like the perimeter somehow? We're missing 10. How am I missing 10? 1, 2, 3, 4, 5, 6, 7, 8. Oh. Ugh. I'm paring the problem down correctly, it seems, but the numbers are not adding up for some reason. All right, let's look at if I eliminate this rectangle, how many do I cut out? It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And do we cut out 12 on the first one? Cut out 10? 6, 5, 4, 0, 0, 1, 2, 3, 4, 0. We're cutting out 2 by 1, 2, 3, 4, 5, 6. We're cutting out 12. I cut out 10. Okay, so that's the problem. This math is not quite right. Because we have to actually consider which edge we're keeping. We're keeping this edge and we're not keeping any of these. So it is there's a +1 and a -1 that we got to figure out here. Because it's not just simple area. So it's in the keeping direction. We need to so the x is correct here. That difference of 2 is correct. 1, 2, 3, 4, 5, 6. It's the y direction we need to add 1. Okay, so we should have like a d keep and a d not keep. And one of them... Oh, let's just break point and figure it out rather than try to brain it too hard. Okay, so we're keeping the y's. So d change equals this is still gonna be off because the end one is gonna be wrong. Okay, so we eliminate 12 there. Still off by a little bit, right? Yeah. Fine, that's fine, that's fine. We eliminate 12 here. 7, 4, 9. That is this chunk here, so we should eliminate 6. We do? Okay, good. So my 50 for this is actually wrong. It should actually be 6 times 11, so it should actually be 66. Fuck yeah! Alright, let's get rid of all our prints. And we'll put back our tests. Oh no! No! Well, that's not great. Okay, so our actual input and our test input also fail on this case here. So let's put our prints back. And uncomment one. Let's make sure this one works. Oh yeah, we know it works because it passed there. Go for code. Oh man, if you wouldn't have used MOTD, it would have worked. These numbers seem really big. 3, 6, 9, 12. 3, 6, 9. Oh, I guess they're small enough. Huh. I wonder what the shape of the last one looks like. It's so big, though. Yeah, like what shape do we have left here? I'm just making sure it actually loops all the way around. Okay, it does. Um, okay, so let's map this out. We start at this one, and we go to this one. So it goes down to this one. And then we go this one to this one. Goes right. Then it goes down to this one. It goes down and then immediately up. Okay, well, that's clearly wrong. That shouldn't be possible. I guess we can write something that checks our assumptions at each step and finds where it breaks and then fix it from there. Yeah, so let's just put this after every And let's uncomment these. Okay, so does well on those. See what mistake we're making here. Okay, so this was the elimination that we made. And what did we have directly before that is the problem. So that's the second elimination. So I'll just put a breakpoint here. Let's actually draw out the original problem, because that will help us understand where the points actually are, and then gonna go to sleep. Sounds good, Melnathus. Thank you for stopping by. Alright, so we have 0, 0, which goes to the right to this one, which goes down. And this is not going to be to scale. We'll figure out the scale afterwards. Down to this one, which then goes right to this one, which then goes down to this one, which then goes right to this one. Damn it. Which then goes down this one, which then goes left, thank goodness. Then it goes up to this one. Goes way up. It goes above this one. This is to the left of this one. Somewhere in here we got this guy. And $356 $919. Okay, yeah. 60K, 40K, 80K. Okay. 468. Yeah, okay. Cool. So we've done this guy here. Wait a second. Oh, this is here, which it then goes up. No, this is a change in X. This goes to the left. Oh, I can do this to move things over. And think about that. But this still needs to be further over. Be somewhat to scale. And then it goes down again to 11, 8, 6. That's the same as this one here. Okay, so I have no fucking idea how this is going to help me understand this problem, but I'm hoping this pays off. I also have no idea how fucked the margin is over here. Oh, it's not too bad. Alright, next song. Alright, so after that, it goes very far over to the left. And then it goes up, and then left, and then to 0, 0. Okay. Y of 50k. No, 500k. This 300k. That's 900k. So it's in here. Ugh. Still on the same problem. Yeah. We're almost there though. Okay, then it goes to x of 0. Oh, gotta indent everything again. To fit this boy in here. And then these connect here. Except we can just put them right on the... Okay, so this is what the sample input looks like. Except I fucked these up. Oh look, it kind of fits on one screen. And it is sort of to scale. Okay. So, let's trace through what the problem does. B194. Okay. So we're eliminating from... We have a right, down, left one. So it should be... Looking at our input, it should be this one, I think. So one of the corners should have 1186328. As the Y? Also the X? 1186328 for the Y. Oh, and 1186328 for the X. So it is eliminating this corner here. So we should make a cut here. And so after this, 8168019196447. Yep, that should connect to 818608111, which should be down here. That looks correct. Delete those two, and then this should be this guy here. Yeah, that looks good. Okay. And then this should fix up this line here to be straight. Instead of 13, after the fix up, there should be 12. Yeah, okay, because we had a straight line there. Okay, sick. That seems good so far. And so then I should be able to continue, hit our next breakpoint. All right, so now it is trying to eliminate, it should be, let's see, right, down, left. It should be this one here. 81608, which is this one here. Right, down, left? Wait, right, down, left? Oh, right, down, left. This chunk here, so it's gonna cut here. So one of the corners is 81608 and 11, which is this corner here. The other corner should be X of 609, should be right there. Y of 56408. So it should cut here, but we know that it's making a mistake somehow. Oh. Wait, so this is one of the corners, this is the other corner. And so it's connecting this point. I think it connects this point to here, but it should be connecting it to here. Hey, what's up, Standard Robot? Hello, hello. How you doing? Look at we right indeed. So I don't want it to make the cut there. Is the problem. Defcan Game says Billy approve. So why does it make the cut there? P1 is here. Wait, that's just completely wrong. Wait, what's P2? What's C2? No, that point is right. So it connects here to here. And then it deletes these 2 points. No, it deletes this point and this point. Which is not right. I mean, it could delete those two, but it would need to connect this to here. And instead it connects it to down here. Huh. How did I get this wrong? Because we got this point correct. That is this rectangle here. But the actual connection point is here. So it is only doing the correct thing when it cuts on the original line and not. So I actually wanted to delete this arc here, and change where this arc goes. Or move this point to here. The first connection it made is correct. I don't think this point is one of the points that oh wait, it should be P something. No, I don't have that point. That point isn't here at all. So this point maybe should have been considered contained. It's not one of the 3 points we have, but it's inside of the curl. And that would get it to skip and just consider this curl. Yeah, let's try that as an idea. Oh, actually, let me remove this for the next time we trace this. So how do I do this? Okay, let's try this with our simple and small ones. Okay, so it still works for those. And it still crashes here, but let's see what it does instead. Oh, but I wanted to change it to greater than or equal to, not less than. Because that would get this. I'm so close to getting this, but I can feel it. We have the test cases passing. Let's fucking go, baby! Oh my god. Whew. Alright. That one was wild. I'm glad we got it though. All right. We have a few more days to do to catch up, though. In the sake of time, I might be just skipping the open source stuff. If one of the problems is quick, though, we'll do some open source stuff. All right, let's do day 19. Only 4 hours in a stream. I'm so glad I didn't do that one live. Holy shit, that would have been a late night. Let's hope for a breather compared to that one. Okay, let's look at 19. A shiny part. Okay, some sort of instructions and data, it looks like. Let me get some value here. This looks like a parsing problem. Bazooka Puka, hello, hello, welcome, welcome. The workflows are listed first, followed by blank line, then the ratings of the parts the elves would like to sort. All the parts begin in the workflow named in. 5 parts go through the following workflows. Okay, so these are little programs. Yeah, they're programs, they're branches. Ultimately, 3 parts are accepted, so they either go to A or R. Exception is that add up the X, M, A, and S ratings. Xmas, yeah. For the accepted part gives that number for the part, blah, blah, blah. So it's the sum of the accepted parts. So these are programs which are just comparisons of particular values, and then these are just dictionaries. Okay. Not so bad. And we have less than or greater than. So we have some sort of little program. And we're going to have an operator, which is going to be a callable int to bool. There's no compound ones here. Oh wait, there are compound ones here, yeah. So we have kind of multiple comparisons. They evaluated using AND. Because this one has... Oh, it's... If this is true, send it to this. Otherwise, if this is true, send it to this. Otherwise, that. So they're ternaries. Are they only nested in that way, though? Like, is it ternary choice yes, ternary choice yes, ternary choice no? Or do we have any that are like ternary? How would I find that? That tells me no. Okay, so it's really just a series of checks and choices. So this is... callable or a stir, and then our default is a stir. Okay, so this is gonna be our default. Any of these parts are our success criteria, and this is our ID. Okay, that's not too bad. Let's parse our programs first. Shall we split? And then we have our default should be on the end. Or split on comma limited to 1. And then we have a series of these things. Oh, but a check also has a make a little name tuple for that too. Keyster comp int bool and dest stir. This is going to be a series of checks. For part in bag dot split on comma. Oh, we need a value as well. Key, and then oh, we need to figure out the operator. Keys are only one character, so that's easy. Key equals comp s0. Comp equals comp s1. And val equals int comp s. Colon. Impulse Bob, hello, how you doing? Bazooka Puka as well, welcome to the stream. What are these called? Checks dot append check. Which takes key and val. Actually, we'll do key comp val and dest. That reads better. So checks equals this. Then progs name equals prog tuple checks and then default. That should get us our parsing. Nice. Now we gotta parse our items. Should be pretty easy to parse. Gonna key in our value item k equals int val_s. Then if value is less than val, then return check.dest. Otherwise, return self.default. So now I need to run the item. And that should be it. All right. Sweet. On to part 2. I don't know how this problem gets more complicated though. Maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings can have an integer ranging from 1 to 4,000. Okay, so it's a big old series of equations, I guess. This is how many things can be accepted. Okay. So this would be a great problem for Z3 if I didn't want to think about it, because we have a big series of constraints. Holy fuck, do we have a big series of constraints? And we can work backwards from all of the accepted ones to get answers, which should just help us narrow ranges down. So we need to basically make a graph from all of the accepted ones through their reverse parts, I guess. So what does chat want to see? 2DGG says you wrote a text editor in Python you're using to write Python. It's true. Which one do you want to see, chat? Do we cheese it with Z3, or do we do the actual computation? I'm gonna start doing the actual computation, and then maybe we'll do both. Yeah, both sounds fun. I don't know. No one in chat said anything. I'm all alone. What are you playing? Oh, you're back on Sushi Game? Is there a new update? Oh. Okay, so for this one we don't care about the parts anymore, we just care about our programs. And I think we actually don't care about the function anymore, so we're just gonna put this back to being a string. We're gonna get rid of op. I use scripts to make my Steam downloads go faster. You should download more internet. This song is looping, so we'll go on to the next one. Go to downloadmoreinternet.com, yeah. Okay, so we have all of our programs now. You got your RAM there too? Nice. Okay, so we need to trace from every acceptance back to the origin and get its possible things. Shouldn't be too bad. The annoying ones are the ones where it's defaulted. I guess those are just the false ones. Yeah. So we need to find all the places where acceptance can happen. And then draw the graph backwards from those. In, all the way to in. We need to trace the paths to in from A. It's kind of tricky, isn't it? Let's start with the ones that have... Oh, this is an interesting one. It's either A or A. There's no choice there. Nikki Woodpecker, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Where was that one? LNX? Yeah. That's a funny one. How many of those do we have in our input? We have a few of them. We have lots of them. I guess we can take all of the ones that are like that and just eliminate them. That should reduce the problem a lot. Not by that much. Yeah, not considerably, so maybe we don't bother with that. Yeah, it's tricky because in branches out to a bunch and then it converges. Well, no, it doesn't converge. It just branches out a bunch. We just have to trace everything backwards, which is tough because we don't have we don't have a good marking here. Oh. Like, assuming we know this one. We're accepting this if it is greater than that. And we get to ln x. ln x can come from here and maybe somewhere else in here. So we need to find the reverse mappings of all of these. And their constraints that they add. Yeah, because computing these all is not going to be helpful. We had another range reducing problem in this as well. Oh, I see what we have. We have a bunch of nodes, and we have the constraints to get to those nodes. So px to qkq is this. To get to a, we need to be from px, we need this to be false and this to be true. So we can build up all of the nodes there, and there's going to be a lot of except ones. Yeah, let's try and do that first. So this is going to be source conditions target, I think. Okay. I don't know if this is helpful anymore. For check-in checks, we are going to do nodes.append. We have our source, which is our name. We have our failures. And we have whatever the success of this check is. So we have check.key, check.op, call it operate, comp. Check.val. And this will lead to check.dest. And then we need to do failures.append, check.key, check op, check.val. And then we need to do nodes.append. Name couple failures. And then default. So let's see what that gets us for the first couple of problems. The first couple of programs. Append takes 2. So you're supposed to be a tuple. Okay, so PX, we have less than 2006, we go to this. If it is greater than or equal to 2006 and M is greater than 2090, then we go to A. Otherwise, we go to RFG. Okay, I think that looks right. After that, we should get our graph. This is our graph. And so this is our graph based on what is accepted. And so then we just need to trace each of these backwards. But each of these could fork out to a bunch of different ones. And eventually they need to trace back to in. And it's going to give us a whole bunch of sequences. And then we compute all the constraints on each of those sequences for the possible ones. PP is pretty print. Wait, they should only go back to in. How do I... At some point we get to multiply a bunch of numbers together. But I'm not sure... I guess it's the number of x's times the number of m's times the number of a's times the number of s's. So this number, this big number down here, should be less than that. And it is. Okay, cool. Great. Oops. Okay, that seems fine. Yeah, and in theory, by the end, we will have collected a bunch of conditions, and then we can just evaluate for each of the 4,000 numbers in all of those. That doesn't sound right. That's not gonna get us a big number real quickly. Oh, we just evaluate the 4 sets of conditions, and then we yeah, so we're gonna have a big chain of ands, and then we'll for them all together. First, she says, how do you keep yourself motivated for coding? I gave up after graduation a year looking for a job in Canada's job market. I don't know. I have fun doing it in my free time. That helps. But yeah, I actually don't need these types anymore, so I'm going to get rid of them. And this becomes failures. Then okay. Lou 1986, hello, hello. How you doing? You're still missing 1 star for day 21? Well, I'm to a 19 right now. I'm behind. No Timer says, I just read about how RPython and PyPy works. It's actually crazy how meta it gets. Oh, it's very meta. Incredibly meta. Yeah, so we're going to find every path that ends up at A, trace it back to the beginning, figure out the constraints for all 4 of the letters, and then multiply those together and do that for each path that ends at A. Is going to be our plan. And we could also do this forward instead of backward. RPython is a Python program that takes your Python program and turns it into a C program, so you can use RPython to compile RPython, and then you can use the compiled RPython to compile PyPy, which is a Python implementation of Python. Yep, 100%. There are other languages that can be implemented with RPython as well. I've seen that done. Yeah, so I wonder if I just process this forward instead. No, I feel like backwards is the way. All right, let's try and do that. Even though I don't have a great data structure for all of the ways. Like, is there only one way to get to PX? Like, I feel like each of these are gonna have multiple branches, but I think they only can have one unique target. And the rest of them must be A or let's see. Yes, that is true. I'm gonna say doing AC first time full on, it's a pretty big commitment to get up at 6 every day and balance with family life and work. Might need some sleep next week. Yeah, it's true. Imagine if you had to stay up at midnight, which is what I did last year. Okay, so it sounds like there's only ever going to be one way to get to a particular node. So we don't have to worry about multiple ways. So we can actually build our graph in reverse. So we can say that this plus these conditions gets us to here. We need to just trace it back to eventually to input. But this can be our key, except for, I mean, we'll remove the ones that are destination R. We'll keep the ones that are A. Dustjoin, hello, how you doing? Okay, so this should give us our graph. So these are all of our successes. Just saw some in the evening when the kid was in bed. Pretty limited in the morning, makes sense. Remember one of those Alice, recommend one of those Alice style keywords. I don't know. Nope. Need to get fast next year to finish early before my wife gets up. Okay, yeah, I think this is what we need to do now. So these are all of the ones we need to consider. Oh, this is our routes. And those are our ways to get to in. So we need to process these until we get to in. And collect all of the conditions along the way. Okay. While target does not equal in, so this has 4,000 plus the big A's plus the big M's plus the small S's, I guess. I seem to remember it being GE. Instead of GTE, which is what I would probably say it as. Is this going to be slow still? 500 times 4,000. It's gonna be a little bit slow, but I think it'll still work. Yeah, that's not that many iterations. So there is a faster way to do this by reducing the ranges down, but I don't care. For s op val in conditions, let's see. Okay, so for each path, we compute its conditions. Then for each character, we compute how many things are possible for that number. We multiply the number in the path by that number. Is list of tuple stir, and then tuple. Oh wait, no, this is tuple of stir int. Yeah. Oh, and then we need to sum those up at the end. Total plus equals 4. Huh. I got a suspiciously large. Oh, does it include 4,000? 1 to 4,000. Hooray! Oh my. Oh, okay, good. It's fast enough. We take it. GG says blue. Thank you, thank you. Okay, kind of cool. Little graphy. Not too terribly bad. I like my solution for it though. Day 19. What is the current day it's up to? Well, what the fuck is today's date? The 23rd. Oh god, we gotta do 4 more. Alright. I gotta fill my water though. So I'm gonna do that real quick, and then we'll do the next day. I'll be right back. We're back. I was looking over here. I lost my chopstick, but it was right in front of me the whole time. Alright, let's do day 20. Day 0, day 20. Another graph problem, it looks like. Maybe an instruction set. Flip-flop modules are all off. Low pulse is sent to the broadcaster. Never push the button if modules are still processing pulses. Pulses are always processed in the order they are sent. So if a pulse is sent to A, B, and C, then module A processes its pulse, then sends more pulses. Then pulses sent to B and C would have to be handled first. Okay. 3 destination modules A, B, and C. Each of these modules is a flip-flop module. Okay. A outputs to B, which outputs to C, then outputs to another module named IV. IV is a conjunction. Okay. Pushing the button once, the following pulses are sent. So it sends to A, B, and C. Then A high to B, then B high to C, then C high to IV. Okay, so it is breadth first, not depth first. Got it. Okay, so it's a queue. And there's a bunch of examples. Okay, so it's multiplying the number of high and low for 1,000 iterations. Okay, so this is another recurrence problem as well. Shouldn't be too bad. Okay, so we need to figure out what the broadcaster is, and we need to figure out the types. There's 2 types? There's memory and not memory. Flip-flop and conjunction and broadcaster. Okay. So what is the flip-flop? Flip-flops are just inverters? Either on or off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. If a flip-flop receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Okay, so these have state. These remember the most recent pulse from each of their connected inputs. Initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that input. Then if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. Okay. So we need to know all of the things that feed into a conjunction module. It sounds like. Got it. And these are their outputs, not their inputs, right? Destinations. Okay, cool. All right, so let's parse the conjunction modules first, or let's get the broadcaster, I guess. Well, we'll get the broadcaster last because then we need to process it. So the conjunction modules are the most complex ones, so we'll get those out of the way first. These have state. And they have their destination. This. And our flip-flops also have state. And they're initially low. But they don't have complex state, they just can be a bit. Maybe you just parse the flip-flops first. We can't actually use immutable here. We could just cheat here and say, yeah, I'm just gonna cheat. I have a mutable structure. Oh, actually, this doesn't need to keep its targets separately. It does. This one does not. And we'll give them a process. We'll implement that logic there. We can actually parse all these at once. Yeah, because we can just keep track of mapping. This song is looping. do we initially send it a hi? Sends the same pulse to... Okay. We'll figure out the actual implementation for these in a sec. I want to get the structure out of the way first. Nikan Gosh, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Oops. Okay, so when we process something, we need to figure out its results and put them onto a queue. These are actually not none. They are to a list of tuples bools. Bool. Did I say hi to you, Captain Chiga? If not, hello, hello. How are you doing? Good to see you. Why did I capitalize the C? Okay. Alright, so now that we've processed all those, we need to figure out the actual logic for these. When you push the button, a single low pulse is sent directly to the broadcaster module. Okay. So our things will retain state. And so I think for part one, we're just gonna brute force it. It says, I know the basis of programming from started classes. What is the next step? Here's my advice. Eight low pulses and 4 high pulses are sent in the first example. Okay, so the broadcaster push is also considered as one of them. Oh, maybe we just put that in here. Broadcaster and false. That eliminates our special case. Okay. Simple example. This number. In the second example, it's already kind of a big number. So I'm a little bit worried about our sample input. Oh, right. It didn't actually fucking implement anything. Okay, broadcaster. It always sends the opposite of its signal or the same? Receives a pulse that sends the same pulse. Okay. Return target high and self-data targets. Great. Flip-flops are either on or off. They are initially off. If a flip-flop receives a high pulse, it is ignored and nothing happens. Okay. If high, return. If a flip-flop module receives a low pulse, it flips its thing. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Okay. So, otherwise, self.state 0. Inconsistent math. Thank you for the follow. Welcome, welcome. Hopefully you're doing well. Invert the state, and then target self.state 0 for target in self.targets. Flip-flop done. Conjunction. Remember their most recent received from each one of their connected input modules. Oh fuck, we gotta pass along where they got this from. Okay, well that changes things a little bit. Not by much though. Oh, and these things have to know their own ID. At least that makes it more convenient. Oh, we didn't actually implement this guy yet. Okay, how do you do? Remember the type of the most recent pulse from each there. They initially default to remembering low for each. When a pulse is received, the conjunction module first updates its memory for that input. Self.input source equals high. Then if it remembers high for all, then it sends a low. Otherwise it sends a high. Okay. If all self dot inputs dot values, then it's high for all of them, then it sends a low pulse. Otherwise it sends a high pulse. Okay. Okay, so if they are all high, then val is false. If there's one of them that is low, this will be false, and that'll be true, and it'll send high. Key error output. What the fuck is output? Did I copy the example wrong? Oh no, there's an untyped module named output for testing purposes. Just make it do nothing. Key error output, but why? Oh. Oh, it's so close to being right. Well, shit. I guess we run the second example and see what it does. What does their output look like? Yay, where's our breakpoint? Oh, god damn it. Alright. So that's where our problem is. Con low to output. Who is con? Con is one of those funky things. So con should know about B, but for some reason does not. Why does it have A true, B true? Did I set them wrong? No, it's false. How the fuck did you get B true? All right, let's look at this. It has no inputs yet. They should have. Oh. Oh, right. These don't exist yet. So we gotta do this in a second pass. Burp. Okay. Hey, kind of slow, but gets us there. Part 2 is going to be like, run this for infinite time. Infinite number of iterations. The final machine responsible for moving sand down to Island Island has a model text named RX. The machine turns on when a single low pulse is sent to RX. Reset all modules to their default states. Wait for all pulses to be fully handled after each button press. Okay, we don't have any test cases. We're just gonna run it and see what happens. Maybe this day was just easy. I suspect it's not. I suspect I'm gonna have to reverse engineer the program, which is going to be fun, I guess. Reset all modules to their default states. Wait for all pulses to be fully handled after each button press. What is the fewest number of button presses required to deliver a single low pulse? A single low pulse? Is that the first low pulse or exactly one? I'm gonna assume it's the first low pulse. Peter go burr? Yeah, it's time to reverse engineer the program, it looks like. Damn. I was afraid of that. That might take a while? Yeah, I figured. Alright. We're gonna muck around with our input here. Oops. A lot of these right into this little motherfucker. God damn. These each multiply the number of like hits they need to get in order to happen, which makes them exceedingly rare. Alright, let's pop out each of these guys. We're kind of building a graph here, it looks like. A lot of them hit this HZ guy. At least we're two not flip-floppy dudes anymore, or not combiner guys anymore. Okay, cool. What about CN? I'm just gonna control C. There's no way that's going to succeed. And oh boy, I hope there's no like CNs down in these ones or these ones. Got 9 in each of those so far. We only have 8 there. Oh no. Okay, maybe that's fine. Okay, our last dude that I'm gonna think about is our GH. And GH only has 10 as well. Okay, so then what the fuck are the rest of these dudes? And our broadcaster up top. And he's gonna filter down through all of these. Here is CX. CX is down there. Oh boy, it feeds back to itself. Okay. Where is ZQ? ZQ also gets fed back like that. What about TV? Same pattern. Same pattern. Where does BD come in? BD is also a little loop in there. Okay, so I think what I'm gonna do is look at each of these guys and see how their inputs change each time they get pushed. But I suspect it's like 2 to whatever this big number is, plus or minus a few. And they probably blink with some periodicity. Like we get some state increment after a while. Would be my guess. Uh yeah, that's why I couldn't save it. So let's figure out. Let's put a breakpoint after each loop and look at our C's. This is unhelpful. Maybe we'll represent the C's as their list of bits. That doesn't feel right. Expecting curly brace. Let's do this, cause that's going to be easier to read. Where did I put a parentheses there again? Song is looping, the next song loops. We'll go to this one. Oh, look at their bits. MF's got a whole bunch of zeros. Still zeros. What changed here? This guy moved, this guy moved, this guy moved, and that guy changed. So what did I determine from our input? These 4 feed into MF. MZ comes from a single place. SH comes from a single place. JF comes from a single place. And BH comes from a single place. Okay, so we have to figure out the periodicity of each of those 4 and multiply them together. Maybe is my thought. Because we need to get this one. So how do we write that programmatically? It's also the periodicity of these guys. I don't think these 4 dudes have output anything at all. Not for a very long time. Meatsaw says, heading off. Did lots of chores while listening to you. Good luck and Merry Christmas. Well, thank you for stopping by. Appreciate you hanging out. The 4 dudes all just have 1 bit input. We can just find out when they are called. Alright, we got our 4 MFs. What's up?
You're so lucky.
Oh, yeah. So we need to find a high signal from all of those. It's probably not that. It's probably... How does this function work? Why is it not like map that prod? Well, those are the same value. Because those are probably all primes. Am I doing 1 to 23 today? We're certainly trying to get through as many as possible. God, I hope that number's right. Thank God. Thank fuck. Fucking MFs. There's no way this works for anyone else's input, but... Vision for all! Hello, hello. Cool. Little comment, because no one else is gonna be able to figure out what that does. Day 20, hooray! I'm curious how you approach 21 part 2. Well, we're about to get there, so stay tuned! Ah, is this going to be a game of life problem? Certainly something. He needs to get his steps in for the day, so he'd like to know which garden plots he can reach with his exact remaining 64 steps. Ah, I see. Bostosaura Rex, thank you for the follow. Welcome, welcome. Hopefully you're doing well. The start position, garden plots, and rocks. Okay. I'll start the starting position, which also counts as a garden plot. Then he can make one step north, south, east, or west, but only onto tiles that are garden plots. AKA those. Then he takes a step, since at this point he could be at either tile marked O. The second step would allow him to reach any garden that's one step north, south, east, or west, or any tile that he could have reached after the first step. Okay, because it's an even number, it's not just how many can he visit, because he must walk a step. But I think it's just going to be the total over 2. Because it's not diagonals. But I'm gonna try that and see how close it is to the answer. And is his starting position allowed? Yeah, his starting position is allowed because he starts on a garden plot, I guess. Okay. Let's try it. Part 2 is gonna be just big number, almost certainly. Alright, so sheen equals a set. It's actually not quite that. It's probably even odd. But we'll figure that out when we get to it. And for part 1, we can just... Yeah, this probably isn't going to be that big. Don't even need to do that. It should be much, much larger. Wait, expected is 16 and I have this massive scene. That doesn't seem right. Oh, this is 6 steps, it's 16. So steps count. So this should be too large. And what was the start? So odd, odd. Why is there just a fucking 5 in here? How did the 5 get in there? Oh. I was wait, what? Alright. Thing should be this, and generator has no length. Okay. Order's not defined. God damn it. Do. Okay, so the possible things should match the even oddness of start. Hmm. Too low. Oh, I don't have this right. I need to add them up together because these are the diagonal ones. Yeah. So hooray! Sweet. So a larger number, but not uncomputable. Blue 1986 says, "Here we go." So the infinitely repeating map's not a huge deal. The number of operations isn't a huge deal. The size of the set is a big deal though, because after 5,000 it's this absurdly large number. I think if we run it for a while, we should see a pattern. Maybe. And then it's just math. Yeah, because basically with the tiling, adding one step should just get you, like say you have this start position. You won't ever see that start position again, but you'll probably see one where there's just a single dot on this position in the map. And so then you know that incrementing one will get you this number more. So you can just compute all of the combinations of those and then the combinations of maps. And the map isn't that big. And then it's dynamic programming. It's how many maps you have of each type and how many maps of new maps you get out of each type. Yeah, okay, that's how we'll do it. Ugh. And it should be easy to verify with part 1 by having a small number of steps. So I'll just actually keep the test suite the same. Oh, maybe we'll do input and an expected. So 6 is 16. All steps. And so we can take their numbers down here. That'll probably be enough to demonstrate the idea. Is that going to work though? Is it an odd number or an even number? It's an odd number. No. Are there any odd examples? Oh, they're fucking all even. Well, we can deter. Actually, our it should just be the opposite of what we have, right? Yeah, it should just be the opposite. Hmm. We kind of have to figure out how many. So we're gonna have like fully processed maps, and then our edges will be non-processed maps. I think. Hmm. I wish I had some examples for odd numbers. Well, I guess we can get from 5 here. Like we have 1 and 2. And we can probably get the one right before 6 as well. Oh, this is 3. I have an idea how to solve it, but I got the wrong answer 15 plus times, so my approach might not be the right one. Ah. Yeah, that would point to that. Let me try and get my solution working for odd number days, just so that that is out of the way. Two failed, 3 passed. Oh, because it doesn't do the infinite tiling thing there. Oh. Okay, so that's the brute force. Let's give it a very big number. And just see how slow it is. Convince myself that I need to not brute force it. Yeah, so this is taking forever. So eventually a tile will become completely filled, I think. The tricky part is the evens and odds. Well, everyone says, are you the creator of Pregament? Yeah, that's me. Well, Pregament.com. My whole team's been using it for 3 years. Nice! It turns 10 years old next year. Believe it or not. Okay. So it's kind of going to go outwards. It's gonna fill outwards. Oh, we don't actually need to do the computation, do we? Except that there's probably maze elements. Like there's going to be parts. That's kind of funny. There's a very clear diamond shape here. Like there's going to be a different rate of filling in different directions. Where's the S on this? Oh, right in the damn middle. And my guess is that it's not going to fill evenly. I kind of like my original idea, but I don't quite know how to implement it. Because if I treat it as a series of cards and then increment the number of cards each time, I won't know how filled. Yeah, let me know what I'm talking about. Like we kind of have cards like this, like so. Once one is completely filled, we don't need to process it anymore. We only need to process the ones that are on the edge. Blah. I don't know why it's okay. Anyway, we only need to process until something is completely filled. Once it's filled, we know that it's just going to alternate. And then you could say that like a card that has this pattern on it will always result in another one. Purple Elf, hello, hello. How you doing? Thank you for the raid. Welcome, raiders. How was your stream today? We're just working on some advent of code. Here for the Bob Ross segment, yeah. Zion Bear, hello, hello. Appas Babas, good to see you. How was your stream today? But I don't think this quite works because we don't know, like, for instance, just looking at this card, we don't know whether this one has started, these ones here have started or not. Well, Ford, thank you for the follow. Welcome, welcome. I also think that just trying the perimeter cards might work. Like, until a card is unfilled. But that's still a very large number of points. Don't think that's too slow though. It's like the number of iterations we have to do actually isn't that large. So I feel like, where did my damn window go? Like this is only 26 million. Like that loop is not that big. Right? Oh, Pepe's gonna optimize this out. Okay, it's kind of slow. Yeah, don't tell me what to do, Miserex. I don't give a shit. I'm not gonna do what you want me to do. Still kind of slow, so it's probably not actually doing that. Because we need to do a fuck ton of work in each of those loops too. So it's probably, we need to figure out a function for how much it increases each time. This looks like a day I would skip. Gotta get them all done. So I'm curious. Here's what this looks like. It's the only star I'm missing right now, Purple. It's a good interpretation. It gets real slow right around here, so maybe we won't send it all the way to 1,000. $250 should give us enough. It's really crawling at the end there. I should have made it tab delimited instead. Oh, there's space delimited is probably fine. Oh, god damn it. What the fuck? Why why doesn't it paste it as cells? Maybe you do want tab? Five more hours until day 24? Yeah, I know. S1 Cube, thank you for the resub at 32 months with some biscuits. There we go, that let me paste. Thought was to look at a chart of this and see what it looks like. Cool. Roughly exponential. Sort of warbly. I don't know. I don't have any things that just like magically curve fit those though, so that's not quite gonna be helpful. Yeah, I don't know that that helps me. This is perplexing. I'll leave you out because I know my brute force isn't fast enough for it. I might come back to this one. Yeah, I might come back to this one. I have some ideas, but I don't quite know how to put them into code yet. So let's get this one for now, just like Blue did, and we'll come back to it. This will help us get caught up faster. Rather than stewing on this while I'm not thinking about it. Okay, so let's skip that for now. Rardy Pants, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Did I actually change this? So we have our prints in there. Okay. Since we know that now works for odd. Day 21, part 1. Alright, so we're gonna skip part 2 for now. Day 22. The top 10 solved it in 15 plus minutes. That's not the slowest I've seen. Like there were some that were hours plus. This is the sample. That is our output. There's bricks falling. Position of a single brick at the time the snapshot was taken. Oh no, 3-dimensional coordinates. This is a single cube brick. Okay, so the bricks have our lines. And bricks never rotate. Two bricks cannot occupy the same position. Okay, so we have to make bricks fall. Seems not the worst. So it's 3D Tetris. Which bricks are safe to disintegrate? A brick would safely disintegrate if, after removing it, no other bricks would fall further directly downward. Bricks can be disintegrated even if they're completely surrounded by other bricks. You can squeeze between bricks if you need to. Oh. It's just any brick that So it's find a brick that something else is on, that either has nothing above it or all of the things above it have things below it that are not itself. This is complex. Good old 3D rendering of the output, which was fun. It's more like Jenga, but the output looks fun. Oh, I hate 3D space. These are the problems every year that I'm like, oh, brain hurty. Okay, so I think the idea that I have here is to make the bricks settle that are minimum Z value. Is that even correct? I don't think that's even needed. Because we can just look, we can just trace upwards without actually having them fall. Yeah, so we just need to find any brick that does not have any other brick above it. Or I guess we need to figure out which ones support other ones. Yeah, okay. No, I'm good for now. Hmm. It looks like these bricks aren't very large. So that's good at least. Okay, let's parse first. I don't think that's the right helper. Yeah, that's not it. Purse numbers, comma. Okay. So then we just need to do intersection. Yeah, what's up, I satisfied? Thank you for the resub at 41 months. It's good to see you again. I hope you're doing well. Wait, that's the opposite of what I want. Hey, you. This also wasn't quite right because a brick could have another brick in between brick. I'm on day 22. Oh yeah, you can't see it. It's right behind here. Which is a 3D space one. Hey, Monkey Man. Hello, hello. Welcome, welcome. Hopefully you're doing well. I guess I could I could simulate them all falling. Which I don't think would take too long. Let's see what the biggest C value is in the sample input. Okay, not too long. D25 is only revealed when you do them all right. Not quite. Sort of. Main Mobile says Jello. Okay. Cool. Not quite blue. It's similar to that. 25 will be revealed for everyone. Okay, so it actually wouldn't take that long to simulate this, so maybe we do a simulation. Hey, Monkey Man, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Yeah, you have some more time. Yeah, I guess we'll just do the simulation. I kind of wanted to avoid that, but is there a way to avoid it? If I sort them by their Z's, I sort them by their Z's. I wonder. Yeah, if I sort them by their Z's, then I only need to look at the ones after it to see if they stack. Is that true? No, it's not true because you could have a thing like this, and then a thing like this, and then a thing like this, and then another thing like this. But this one down here only supports this one. You'd have like a spirally doodad. Yeah, so I think I need to simulate it. Damn. And we're gonna make the bricks mutable. Yay. Want to see a rendering? No, I'm good. I feel like it might spoil it a little bit. Also, I might take a break at some point because getting a little tired of staring at the computer. There's some strange screeching noise outside. Or it's in Tina's game, I can't tell. People are yelling outside, so maybe that's... Bean bean! What? Eggies! Wow. Yeah. Spooky? Do you hear the horrible sound? Is it your computer? I don't know. I hear people yelling outside too, so I'm not sure. That might also be your computer? Hi. It kind of sounds like a school fire alarm. I don't know. It just stopped. Did you hear the sound that just stopped? Damn it, God, crazy. No, not in the song. It actually says. God, I hope not. The formatting you made for unit there, sadly, auto formatters sometimes take the beat out of such manually styled code. Yeah, I mean, I did this mostly because it's easy to read. Although I think like, yeah, my formatter is gonna be okay with it. Yeah, fixed it slightly, but. And this is a syntax error, but Hooray, bricks. Okay, so yeah. Okay, so it said Z1 of 1 is the lowest value that it can reach. Manny Mobility says, I love bricks. Okay. Okay, so we need to check if a brick is supported. By checking against done. Okay, so now we need to implement this supported function. Okay, so they need to have a Z1 directly above, and they have to intersection of squares, which I can't be arsed to. I always look up or collision detection of literally the first line of Python I've ever written. Are the sides of one rectangle touching the other? No, that's not quite right. No, that's arbitrary axis. We don't care about that. Fucking A. Where did my window go? Will the VOD be available anywhere? Yes, they will be up on YouTube's. They no longer go on Twitch because of DMCA shenanigans. MDN game techniques. Here's what I want. Yoink. Wait, is this collision or not? This is collision. If self dot x1 is less than or equal to brick dot x2, and self dot x2 is greater than or equal to brick dot x1, self dot y1 is less than or equal to brick dot y2. Why did this never get printed? Oh. Because I didn't put it back. Is worth adding that link to your Twitch page? Is it not there? YouTube. Oh. Yeah, it doesn't only link to there. Yeah, I should probably add that at some point. Well, that doesn't seem right. Because that would indicate that they all fell to the bottom. Is that where I work in PDB? Not always. Sometimes, not always. It depends. It also depends on how your Python is compiled due to stupid reasons. Oh, this is backwards. Doo 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 doo. Yeah, I like that better. Okay, we've settled all the bricks. Now we can figure out how many we can delete. Oh, we want the other way around? Four! Fucking A. Hmm. Does it say what the bricks should be after they've all fallen? Sort of. Oh, what's the highest? Z is 6? Wait, this is Z9. Oh, this is before they've fallen. Okay, so Z2 of 6 is what we should see. Yeah, we do. So that's this one. Should see. I mean, we didn't give them names, so we don't really know which one is which. A is down at the bottom. Yeah, we didn't give them names, so I don't fucking know. That's this one, yeah. So that one is already at the bottom. Great, cool. This one was already also at the bottom. Huh. Oh, wait, I'm doing the computation wrong. We need to find ones where its parent is supported by. Maniac, thank you for the resub at 2 months, which gets you a fancy new badge. It's good to see you again. I hope you're doing well. YMX is heading out. Well, thank you for stopping by. Good to see you. If brick dots supported by other, then supports J, not append I. And supported by I dot append J. In both directions. And we actually want set because we're gonna do double the work here. My family thinks I'm cuckoo watching Twitch streams at 6 in the morning. Oh no. We'll just sort them in order, cause okay, what do we get here now? Import error. WTZNC says they're right. Yeah, perhaps. Dick int set int. Oh. I have to do this in the other direction. Do I use PyEnv? No. Not unless I am forced to. Oh, I reintroduced the bug. Set has no, yeah, it's supposed to be add. I think it can be append. How the fuck is 0 supported by 0? How does it support itself? Oh. Off by 1 error. Do you have a video on how you use virtual items, your configurations around if you have any? I do, I have bunches of them. I also support myself, I can't break through the same. Right? There's a whole bunch of videos on virtualenv if you search my channel. Yeah, see 9 others. The easiest way to search this is to, oh, it doesn't link to the GitHub for some reason. The easiest way to search this is on GitHub because I have made too many videos. Okay, so if it supports something that has multiple supports, then it doesn't matter. Rangeland, gross. If supports I, not supports I. Yeah, I'm just not braining at the moment. Total plus equals 1. Otherwise, all of the things it supports land supported by actually this is true even if this is empty. Then total plus equals 1. One. Oh, it should be greater than or equal to 2. Greater than 1. Hooray! Unchained Ninja, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Too high. No, I have to debug now. Bummer, because I might have the right input. I don't actually know though. Let's try and reproduce the diagrams that they give us, because that's helpful. How would I do that? How would I do that? Let's see, the first one they do, well, ignore it. I don't care about the original diagram. I only care about after they're settled. X to X0, 1, 2, 0, Z to 0 to 6. Well, it's +1. Zero, 2, 3. Okay, so that'll guess the XZ. Oh, this is supposed to be... No, this is right. Oh. No longer bricks. It is now done. Mine's upside down, but that's fine. A question mark, D, E, F, F, G, G. Okay, that looks fine. So let's look at it from Y, Z. BC, multiple things, FGG. Fuck me. No other bricks would fall further directly downward. Part 2 is going to be what's the maximum number that can be disintegrated, almost certainly. But I can't even get part 1. That probably tells me that my settling is wrong somehow. I wonder if I'm making an assumption about the sorting of the input. Because it seems like the input is not in sorted order. Do I usually finish all 25? Yeah. Do I usually finish them during AOC? Also yes, but maybe not this year. That's a smaller number. Oh, thank God. Well, YouTube has started to do that thing where it doesn't autoplay the next video. Alright. Considering bricks one at a time isn't going to be fast enough. What might sound dangerous, what you really need is a chain reaction. I'm gonna figure out what the best brick to break. For each brick, determine how many other bricks would fall if that brick were disintegrated. Oh, this is easy. Okay, this is easy. Let's just simulate over and over. Is it, how many would move? Yeah. Okay. um. Yeah, I mean, we can just simulate this. There's not that many inputs. The annoying thing is copying all these bricks around. uh, it's really just how many would move, right? I wonder if I do this, it will let me start over my playlist. Can be really loud, I'm sorry. Oh, I got it before it started. I feel like there's an edge case I'm missing here. More than just my syntax error. uh, no overlative sort of list matches key equals. Did I fuck that up in part 1? I did. PyPy must have just been okay with it. Zero. Oh my god, I did this again. I did this again. Oh, I should have just reassigned done to bricks and not fuck myself up so many times. I don't think this is gonna work. It's gonna be pretty slow, but it will spit out an answer, but I don't think it's gonna be right. Probably something I'm not thinking about. Oh, you know what? We'll take it. uh... Alright, there's only one more that I have to do, day 23? Okay. And day 21 part 2. But I might need a thinky break for that one. Hey, what's up, Dota? Hello, hello. How you doing? It's like a maze. Looks more like a maze when I actually open it up. Hiking trails. And slopes. We start there. Start there here too. Cool. It's the single path tile in the bottom row. Because of all the mist from the waterfall, the slopes are probably quite icy. Step onto a slope tile, your next step must be downhill. In the direction the arrow is pointing. Scenic hike, never backtrack. What's the longest hike you can take? So we're trying to maximize distance. Shortest distance is easy. Longest distance is much more difficult. Although, if we look at the input, it's very narrow pathways, so I suspect that there won't be too many different paths, so I think we'll just run the maze and see how it goes. Can we walk diagonal? My guess is we cannot walk diagonal. So I think we're gonna have just all possible paths and try them out and Yeah, just run it to completion. I can't really. I'm not good at finding longest paths. Yeah, we're catching up on AOC. Indeed, indeed. Right. I think that's right. Oh, we should also grab the. Doo 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 doo. 94. I have the chords backwards, but I have the right math. I find it interesting that the problem states that Bill's Skincare says, seriously, this is your favorite editor. You've probably never even fucking heard of this editor. Look closely. Things are not what you may think. Okay, so the arrows are just we can't enter them from the wrong direction. Bro, tell us a little bit about the editor. What makes you use it? Ah, well, funny you may ask. You can actually find out more on my YouTube video. You know about it. You've heard of it before? I don't believe you. Because this is the first time you've been in my stream. Is it not? Oh no, you've been here before. Why wouldn't I pick an editor that I made? Why would I bother making an editor if I'm not going to use it? Okay, so yeah, this isn't terrible. I'm going to represent paths as a position. Start and start. Oh. This is the default editor that comes with Ubuntu. No. Look closely. Look closely. It is not the default editor that comes with Ubuntu. Look at your hands from above. You can see why Vim uses HJKL because I use the arrow keys. I mean, your hands are kind of naturally shaped as arrow keys and not as HJKL keys. What? What? What, are you gonna let the Vim cells win? What? Yeah. I don't think that's true. New paths equals this, for path in paths. Or I guess for I'm gonna use direction 4 because the directionality is important. For D in support.direction4. Can equals D dot apply pause. Where am I from? I'm located in the Midwest right now. What is it used for? Are there only right and down slopes? Oh no, there's all 4. Okay. You dead behind Bring Man? Yep, that's me. New pass dot append cans and then bean cans. Guess I don't need this +1. Kind of slow, but it gets there. Isn't as slippery as you expect. Oh wait. I can use Dijkstra's just backwards? Kind of? There's no way that... Oh, it looks really funny while it's scrolling. There's no way that this would be fast and like there's no way a day 23 problem would be this straightforward. Zero. Oh, we need to like there's no way. There's no way it's just run it, because there's gonna be way more paths. Yeah, I don't think it's just run it. I think that's gonna take an absurd amount of time and memory. Especially because I'm doing just breadth first. Okay, so there's a more clever way to do this. What is it? Maximizing paths. Maybe I do depth first instead of breadth first. That'll at least get me an answer, and then I can narrow it down. Yeah, so the problem is finding other ones that are going to be larger, and so I need some way to prune. I feel like I've done something similar to this before, where you find one answer and then you have to try and find things that are bigger. But I don't really know what to prune on in this problem. Oh. My solution for part 2 ran for about 40 seconds and was pretty optimal. 40 seconds? That's huh. It's quite a long one. I think there was a similar problem to this in a previous year where you basically just have to find all of the decision points, and then it's the paths through all of the decision points. Because those are the only like interesting connections. You okay? Oh. Because then you don't actually do any pathing. It's really just graph problem. So I'm gonna try and do that. Basically, make nodes for all the interesting points, and then compute all the get all the connections through those. It'll still look at every combination, but it'll be faster. We won't actually do any reversal stuff. Oh, that's not even the right problem. Where's that one? So I basically need to find all of the points that have multiple points. So we have nodes equals yeah, we gotta find the connections between all the nodes. And I don't think there's any, I think it's drawn in a way that there's only ever forks, there's not like marble paths. So yeah, okay. So let's figure out all of the reachable nodes from, so I can find the positions of nodes too. So like we know this is a node. Part 2. I haven't done 21 Part 2. But yeah, I'm gonna. What's up? Okay, have fun. Did you have dinner? Oh, I thought you went downstairs for a bit. For cornbread. Cornbread was dinner. Are you hungry? Do you want to get food? Right now? Okay, I don't think it's gonna take too long. Pressure's on now. To do. Um. Oh no. This has the old code here, but the new code here. Okay. I've been meaning to implement that fix for a while, but I have not gotten to it. Okay, so we have a series of nodes, and then we need to figure out all of the connections between each of the nodes. Then we know the lengths. Um, yeah. I need the part 1 code. Candidate is in nodes. Then connections node dot append. So if we reach a node, then we have that weight computed. The King UI, thank you for the follow. Welcome, welcome. Hopefully you're doing well. How did it connect to itself? Oh. Akupanu, thank you for the follow. Welcome, welcome. Hopefully you're doing well. Okay, so one must connect to here. This can connect to 3 different nodes. Just making sure we don't see ours like a repeat in here. Okay, so that's our weights. Got quite a few connections here. So now it's just graph traversal, hopefully. Oh, and we want length. For cost and node in connections, pause. If node not in, if node in scene, continue. If node equals dest. Total cost. Karuma, thank you for the follow. Welcome, welcome. Size plus cost. If total cost is greater than maximum, then if node not in scene, then part is not defined on line 59. Oh, right. Writing too much other language. Still chugging away. Now, how the fuck did I get... How did I get a bigger number? Oh, because I printed this in the wrong order. Hooray! Mine only took 16 seconds. Well, it's PyPy, so it goes a little faster. Yeah, that's not terrible. Connections will be dict tuple int lists tuple int. Cool. Say 23. All right, cool. What's up, Pylang? Hello, hello. I'm actually gonna take a break, and then I might be back for day 24. We'll see. But that's gonna wrap us up for now. My name is Anthony. I upload educational content to my YouTube channel at youtube.com/anthonywritescode. So go check that out. If you missed any part of the stream, you can catch up on the VODs channel because it doesn't go up on Twitch anymore because DMCA shenanigans. I announced my streams on the Discord. I might try and do a really early stream tomorrow to do day 24 if I don't get it done tonight at Unlock, but we'll see. But yeah, this has been an 8-hour stream. Hooray! That's gonna wrap us up. Let's go find someone to raid.